Hello everyone. So my name is Alexandre, and so I'm from Noveltis, and I will be presenting you a Jupyter notebook. And for this talk, the topic will be iceberg tracking in Antarctica. So as you know, iceberg calving is a process in which big chunks of ice detach from the edges of glaciers or ice shelves. In our case, it's ice shelf because we're focused on Antarctica and drift into the ocean. And so this phenomenon, well, occurs quite naturally, but of course, in the recent years, it gained increasing attention because it has potential links with climate change. With the change of temperature and also the change in wind and current patterns, all those phenomena can weaken the ice shelves and therefore cause more of those calving events. And of course, the drift of such iceberg has also potential impacts on the local ocean circulations, the amount of freshwater input in those areas, for instance, and also, of course, the rise of the sea levels. And so the sea ice drift is, well, influenced by a combination of a lot of environmental factors, currents, winds, but also interactions with the bathymetry, which is the underwater elevation of the Earth, basically, and of course the mass of the iceberg itself and its inertia. And so in this notebook, we'll try to investigate some of those potential drivers for the movements of the iceberg, following one of them as an example, which will be iceberg A76, which is an iceberg that calved from the Antarctic during May 2021, and which is one of the biggest icebergs to have been observed in the recent years. And so we'll examine this using data from WEkEO in this notebook. So first of all, here's a brief overview of the Python libraries that we're going to use in this notebook. So if you're already working with Python, you're probably familiar with most of them. So we'll be using NumPy, which is very common to process data in Python. Xarray is the most commonly used library in Python to process netcdf data, which is a standard file format for scientific data. Matplotlib and Cartopy will be used to draw different graphs and maps of this notebook. Rasterio is used to process raster data, so in 2 dimensions. So it is especially useful for satellite imagery, for instance. In our case, that would be the case. And also, PyProj is a very useful library to manage geospatial computation and geographical projections in Python. So one other thing is that we'll be using the EarthKit library from WEkEO. I'll show you later on how we use it to retrieve the data. Here's a brief manipulation to make sure you have it installed in your WEkEO kernel. So basically, this notebook, I'm using the pre-installed WEkEO Lab Jupyter kernel. So make sure to select it before executing this notebook, and then perform this manipulation here to add EarthKit to your working environment. So this is the cell where you import all those useful libraries. So I've already pre-executed the notebook, so to still catch up with time and just go quickly on this section. Here's the cache setup to store the cache data when using EarthKit. So you can see that we import it here. And then here's a little utilitary function to normalize data, which we'll be using later on in this notebook. I'm just going to make sure everything is imported. Yes. So about the data that is used in this notebook. So first of all, in the first section, we'll be visualizing the iceberg using Sentinel-1 data. So this is satellite radar imagery. So in our case, Sentinel-1 comes with a very wide range of product versions. In our case, as we are exploring a very big iceberg, we are using the extra wide mode of the radar. And yes, and the product that comes in a gridded format, which would be easier to monitor, to exploit. So of course, each of those products have dedicated pages, so you can click on the links to have a more in-depth overview of the products. So here is for the Sentinel-1 images. Then we'll be examining current data. And in that case, we'll be using here a Neckman and geostrophic currents at the surface products, at the surface and at 15-meter depth. So, so yes, in this product, we have hourly resolution, and we have both components of the currents stored. And same case, and same thing here, you can visit the dedicated WEkEO page. And if you want to have even more knowledge on the product, you can visit the dedicated Copernicus Marine Service page, because this is the Copernicus Marine Service product. And in this page, you have access to the user manual and also the quality information document, which will give you very strong knowledge on the product. And finally, we'll be also using wind data, so which is generated with a combination of observation and models. And for this product, we'll have monthly data of surface winds. On the global area, of course, we'll be subsetting the product to our area of interest, which will be near Antarctica. So in this table, we show a brief overview of the data set that we are retrieving, with here the variables. So for Sentinel-1, we're just retrieving images, so we don't have really any variables to retrieve. For the currents, you can see here that we are retrieving the horizontal and vertical component of the currents. Same thing here for the winds, so the eastward and northward winds. So here, once again, you have the links to the product identifier and the dedicated pages. So the product of currents comes in hourly data, but here, in order to save size and because it's more convenient for us, we'll only be retrieving the daily version of the product. Here is a resolution, and here is a temporal coverage. So we can see that as our iceberg was detached itself from the ice shelf in 2021, we can see that for both these, for all of these data sets, the date of the iceberg calving is covered. And finally, additionally, we'll be using also iceberg tracking data from the US National Ice Center. So this is not WEkEO, this is an external data provider. So the institute monitors several icebergs, and so this will give us information on the trajectory of the iceberg. So you can see here, this is the latest data. We have a number of iceberg names with their locations. And so this institute gives weekly updates on the trajectory of those icebergs. So this is where we retrieve the trajectory data of the A76 iceberg. So here's a quick overview of the method to retrieve the data. So in the previous presentation, you already had a glimpse of the harmonized data access tool. So here we're using the Python API of this data access tool. So executing this cell, you will be able to set up a .hdrc file, which will contain your WEkEO credentials. And then you will be able to request data using JSON files. So here is, for instance, the Sentinel-1 request that I've prepared. Yes, it's the one from April. So basically, a data request file looks like this, and you've already seen such request in the previous presentation. Because to write such a data request file, all you need to do is to go to the data viewer, for instance here, choose a product, set up your different filters if you need to. For example, define an area of interest, choose a few variables, So I'm doing this completely randomly. And finally, just click on the Show API Requests and copy paste the content of this page in your text file here and save it as a JSON format. So I've done this for the Sentinel-1 data. I've also done this for the currents here. So yeah, for each dataset, you have a different format. Just go to the data viewer and fill in the formula. And then executing this style, you will be able to process your request and download the dataset. Here you can see that I found one item, which is my Sentinel-1 image from April 2021, and then download it. So I'm doing the same thing here for the May 2021 Sentinel-1 image. Basically, what I'm doing is that I'm downloading two images, one before the calving of the iceberg and one after. And for the Earthquake data retrieval, it's also very simple. So you have to write the same data request files that I've shown you before. And instead of downloading the data in your data directory here on your user account, you will be streaming it directly from the database using so the EarthKit from source function. You just have to make sure that you know your dataset ID, which is well written on top of your data request file. So just copy it here in this argument and then pass your data request as an argument, and you will have your currents and winds directly accessible. All right, so back to the Sentinel-1 images. So you can, when you downloaded the images through the WEkEO Data Access API, it will be downloaded as a zip file here. So in this cell, we just unzip the WEkEO data, and it will yield those two data directories. So a Sentinel image comes as a directory with several auxiliary data. So we want to go directly to the measurement data, which is in the measurement directory. So we want to open this data file to visualize it. So this is what we do here. We're using the rasterio library. And then we are ready to plot the images and visualize the iceberg. So this takes place on the Ronnie ice shelf. So here is the image for the beginning of April 2021, and we can see that the iceberg is still attached to the ice shelf. You can see some sort of little crack here already. And 1 month later, we can see that it is clearly detached from the ice shelf. And yes, it's a very big one. It's about 170 kilometers long and 25 kilometers wide. If you want to, you can try to look for other Sentinel-1 images on later dates to visualize it as it drifts away from the ice shelf and from the continent. And that's what we're going to look at now. So the trajectory of the iceberg. So in this section, we are going to use the external tracking data that we have retrieved from the US National Ice Center. So basically it is stored here. You can see that we have retrieved several data sets from several dates. So we have one per month. We have weekly data, but it is more convenient to use well, only one file per month. So from June 2021, and we go to here, if you look at the file names, to December 2023. So if we open one of those files, we can see that we have, as I've shown you before, all the icebergs stored in the file for one specific date here. So here it is a June 2021 dataset. So what we want to do is to open all of them and retrieve only the data from our A76 iceberg. So we can see that we have A76A, B, and C because the iceberg split into 3 parts, and A76A is the biggest one, so this is the one that we're going to retrieve. So just using a little loop here on the dataset, we are storing all of the A76A data in one new dataset, which will be stored here. And now if we open it, we can see that we have only the A76A iceberg stored at several dates. with, as you can see, its location changing over time. So now let's plot this trajectory and see what trajectory our iceberg had. And you can see here that this is a place where it detaches from the ice shelf, and up to December 2023, it drifted away from the Antarctica and started going eastwards here. And from this point, we don't have any trajectory data available, so it probably means that the iceberg completely melted at this point. So we have this trajectory now, and what we want to know now is that if there are any potential environmental drivers for this movement. So this is why now we're going to look at the currents and wind datasets that we have retrieved using EarthKit. So we've used EarthKit, so we have directly a dataset available for the currents here in this first section. So let's take a quick look at the structure of this dataset. So we can see that we have two depth levels, as mentioned before. So the surface, 0 meters, and 15 meters depth. So we're going to use those two levels because, of course, those two layers may have an influence on the iceberg. We have several, latitude and longitudes coordinates and several time steps. So we have daily data from 2021 to the end of 2023. And we have our two variables here, so the eastward and northward components. If you click on this icon with X-ray, you can take a look at more detailed metadata on each variable. So here, for example, most importantly, the units. So we have water velocity in meters per second. Same thing for the time, the coordinates, etc. And we can also look at samples of the values. For example, here the dates. And finally, we can look at some more general metadata on the product with contact information, the CF convention that is followed by the netcdf file, and yes, potential references that can be useful if we want to know more. So as I said, the two depth layers may have an influence on the iceberg trajectory. So to take those two influences, we're just going to average the dataset over the depth dimension. So this is what we do here. And in the next plot, we can see the current field near Antarctica. So this was plotted using the data that I've just shown you. We can see here in this area that the currents are quite homogeneous, and it starts getting a little bit more chaotic in the higher latitudes. And we can also see that we remember that we had some trajectory data here, but it is not, unfortunately, not covered by the currents dataset that we are using. So in the next section, we'll be only trying to correlate the trajectory and the current data on later dates where the iceberg is already in this area in order to be able to overlay the two datasets. And so this is what we're going to do that we do in this section. So basically, we are just plotting the current field at each date where we have trajectory data. And we're doing this for each of the dates of the tracking data here for the A76A iceberg in order to plot an animation of the trajectory along with the evolution of the currents and see how well the two are correlated. So it takes some time to plot all those different images. So I've already plotted all of them. Yes. So I'm just going to show you the animation. Here it is. You can see the iceberg moving in red here and the current field around it. And if we look closely at the arrows here, we can sort of see that it looks like the iceberg follows quite well the current field that we are observing. So this would suggest that, the currents are quite a strong driver for the iceberg movement. And we're going to perform the same analysis using wind data this time. So of course, this is a very visual interpretation. We try to have a stronger evidence in the last section. So doing exactly the same thing with the winds, same method, same animation. And we can see that for the winds, they are quite homogeneous and go mostly eastwards during the whole duration of the animation. You can see the dates evolving here. So the iceberg does go eastwards most of the time. So this would suggest that winds are quite well also correlated with the iceberg, especially in this part here. But there are probably also other phenomena at play. And if we look deeper at the trajectories, we'll try to see how consistent they are with each other. So basically, what we want to do here is plot the direction of movement and the directions of the current fields and wind fields at the same location and see if the direction are the same or not, more explicitly than on a simple animation. So basically, for each of the product, we're going to retrieve the vertical and horizontal components of the movement or of the fields in the case of currents and winds. And we're going to do this for all of the dates where we have trajectory data. And if we look at the results here that I've prepared, so in blue, we have the movement direction of the iceberg over each time step. Same thing for the currents and same thing for the winds. And we can see that when it comes to the currents, if we compare the orange and blue arrows, we can see that most of the time their directions are very close, going eastwards most of the time. Even when the iceberg starts going in a totally opposite direction, we have the currents also going that direction. Same thing, especially here. Here we have also a strong change in direction. So we strongly suggest that the currents are one of the predominant drivers in the iceberg movement. And we also have the wind here, as we could expect, going mostly eastward, which is also, well, most of the time one of the direction that the iceberg is taking. But it is probably a less influential factor in the iceberg movement. And of course, those two components don't seem to explain all the different movements of the iceberg, which suggests that there are other phenomena at play, probably interaction with the underwater elevation, so the bathymetry of the area. Of course, the iceberg may have encountered other obstacles that can be seen in this data. So yeah, there are some interaction that we can't see that also probably influence the iceberg movement, but we can see that currents is already a strong driver. So we are close to the end of this notebook. So if you're trying to do this notebook at home, we've prepared a few exercises here. So plotting the data sets of the currents at other days to visualize the dynamics of the currents in this area. So we've shown the trajectory of the A76 iceberg, but as I've shown you, there are plenty of icebergs that are also being tracked by the US National Ice Institute that you can follow. And so you can perform a similar analysis on other icebergs. And of course, as I've mentioned before, you can use Sentinel-1 images to visualize this iceberg on other locations. So at other points of its trajectory here. So feel free to go to either WEkEO or the Copernicus Data Space Explorer to visualize other images and visualize the iceberg at other locations. All right, so this is all for this Jupyter exercise. I hope you've enjoyed it, and well, thank you for your attention. If you have any question, feel free to ask.
Thanks a lot, Alexandre, for the tutorial. It was really interesting to see that. So I think, so wait, we have one question coming up. I'll just put it on the right screen. So yeah, not a lot of question. Ah, no, sorry, my bad, wait. Oh, okay, sorry. So the question being, I just wanted to know if you have studied other icebergs or only or only this one. Maybe it was the size that matters for the iceberg.
Yes, I'll focus quickly on this one because it was one of the, I'd say, most famous ones in recent years, and also one of the biggest. So yes, most of the analysis focused only on this one. Yeah.
Okay, thanks a lot. So yeah, I don't see any more question coming about the tutorials. So yeah, we got a bit less of people today, so I think that's why. Yeah, we can wait a few seconds, but okay, you have a question coming right at the end. Okay, this one, so I don't know if you know that and if it's possible doing that with Jupyter, but how can I export anything like a report about the full analysis? I guess you can download the pictures, but I'm not sure about if you can have a report or maybe a text file.
You would say export like a summary of this notebook analysis on
Yeah,
yeah.
that's why I understand.
I mean, you can export the notebook itself in a convenient format like PDF or HTML, I think, but well, you would still have all the code parts written in it. So,
Okay.
I mean,
Yeah, I don't.
there are ways to I don't know, export the different graphs as images, and probably with a new script you could gather all of them in a single file. But it's possible, but it requires some coding and development to export that in a
Yeah,
summarized file that's easy to read, I think.
yeah, definitely. I think you would have to do the summary yourself actually. So okay, so let me check. I'm checking on the chat also. No, I think that's it for the question. I see on the chat that there are plenty of kudos, so I think it was quite clear and well explained. Um, so yeah, thanks again for the excellent tutorial. I think it had a lot of success.